Hey, what's going on, guys? Komakiken's here. In this video, we're going to finally connect our UCI chess engine to the web application to establish the interaction with the UCI protocol on the backend using the Python chess library to actually interact with our chess engine. So let's go to the documentation from Python chess library, and before anything else, I just want to grab this code that allows you to see how your chess engine is playing versus itself, basically. And I just want to create a new folder called engine. Okay, engine like this, and here I want to create a new file called test.py and paste the code in. Now we need to grab an engine, so I will use my latest BBC 1.2 that we've been covering here on YouTube as well. So just copy this one and go into, I guess here, paste. You can use whatever UCI chess engine you like. It would be working like regardless of what engine. So if you want Stockfish, feel free to use it here. But as far as I'm trying to create an ability to play chess online in the browser for my particular chess engine BBC, that's the reason why I'm using it. So now we need to adjust the path. Well, assuming that I'm on Linux, I need to say // and then BBC 1.2. If you're on Windows, most likely you will need to do something engine and then .exe or things like that. I'm not sure how it's done on Windows, but on Linux, this is the way to reference the path. So just to give you an idea where it comes from, if you just open the terminal, the current working directory, if I just simply type BBC 1.2, nothing happens. But if I just type it like this, I'm entering the UCI mode. So what we now need to do is actually to, what am I typing by hands, like UCI new game, and then like go depth 8, say, or 9. It just calculates the stuff. So we need to do this from within the Python script. That's the idea. And also, I just want to open the my system monitor to make sure. Well, I didn't use the quick command, so it didn't exit properly. Okay, and now this sort of a code assumes to be making a chess engine playing versus itself. So let's try it. So I say Python 3 and test.py. Now we see like this is the native output from the BBC engine. If you're using a Windows version of it, most likely you will see the ASCII characters instead of Unicode ones. It's an unexpected engine output warning. It happens because the UCI protocol doesn't say anything about, doesn't say anything about this sort of how to call this, basically extra output in the std out, in the standard output. But anyway, so you can just ignore these warnings because they don't really matter that much. And eventually, the engine was killed, so it's no longer exists here. So if I just run around this again, so while it's working, you have this instance is available, but when it stops, it would just kill the instance, and that's kind of it. So the idea is very simple. We will make engine running all the time within our GUI, but we'll make this a little bit later on. And first, because I'm gonna be implementing this in the most noobs or dumb way possible, just to give a basic idea of how it works. And obviously you can probably make a separate thread for it, especially assuming that the documentation allows doing this. But the reason why I'm not using this sort of stuff, because it works on Python 3.6 and higher versions, while I have only Python 3.7. Sorry, this works with the Python 3.7, but I have only Python 5.3.6. And this and I don't have async.io.run method, so that's the reason I'm not using this code. And also for simplicity, I'm using just this one. And anyway, the engine itself seems to be playing in the separate thread, but I might be mistaken though, not sure. But when I just was when I was researching the documentation, probably I saw something like that, but maybe I'm wrong, not sure. Well, anyway, now let's get back to our web application. So I can actually keep this code for a test for a while, and actually it's not that it's not that bad really to have. But anyway, let's actually, so I'm just wondering, nope. Let's open the terminal in the current working directory and start our web application. So I type python 3 app.py in order to start the HTTP server at the port number 5000. And if I now go to this port number 5000, our application arrives here. And now the idea is we need to establish the interaction between the GUI and the chess engine itself. So between the front end and the back end. Then the way we're supposed to be doing this is via the asynchronous post requests. So every time we're making a move, we would be making a post request to the backend API in order to pass the current board position stored in FEN. Well, maybe it's not the best ever choice, but well, I mean, from the transposition table perspective, it's long to explain why. If you're interested, ask me in the comments. I'll tell you. I'll give you a detailed explanations on my concerns. But interacting between GUI and the chess engine via FEN strings is the most simple and straightforward way of connecting these two. So here we have this onDrop function. And probably just before updating the status, we want to make HTTP post request to make move API. So I'm using the jQuery shortcut for the post request, which takes two arguments. First is the route. So I'm using, let's make a route called makeMove, and then the callback function that fires on success, and it would be returning the data. Well, I call this parameter data. Data would be contained in the FEN string, and later on we'll add things like some info like score, maybe best move, maybe principal variation, things like that. So just to give you an idea. And also we would have passed in some data along with our post request, which is also important. So here I want to send the FEN string, and in order to give this FEN string, I need to use this one, game FEN. So there is a little difference between game FEN and board FEN. So just to give you an idea, what are these variables? So board is the instance, would become an instance of chessboard.js widget, and it has FEN, but it's shortened, which doesn't work for to make a move, while game FEN actually contains the real FEN. So just to give you an idea, what am I talking about? I can print them to the console, so you can see the difference. So console log, and let's say board FEN and plus board.fen, and the same for game FEN. So again, like board is controlled by chessboard.js and game is controlled by chess.js. So here I use this game FEN. It now won't work because we don't yet have that API route, but anyway, I can show you this. Okay, unexpected token, it's interesting. Excuse me. Oh my god, what's kind of wrong there? Okay, let me just try to comment this out for a while. Sorry guys, I just paused the video. I can't. I'm not allowed to press Control R. I'm really sorry for this. So yeah, this is what I wanted to show you here. Oh my god, I really hope that the video was actually recording. Hold on a second. I just want to check that out quickly. Okay, sorry for being distracted. Probably it was working. So here is the board FEN. So the FEN that is generated by the chessboard.js widget, and it doesn't contain the side to move, canceling rights in peasant square, and this half move counters, while the game FEN does contain them. So if we just pass this this FEN to our chess engine, it will be working correctly. I was unfortunate with trying that when I didn't really know that board FEN returns this shortened version of the FEN. I was sure it returns the full-blown one, but then after reading some issues on GitHub regarding chessboard.js, I realized that it's just a dumb board that doesn't know anything about the game state, and that's the reason why the author of the chessboard.js suggests to use this chess.js, which takes care of the board state. So this game variable takes care of the board state, and the FEN presented here is exactly what we want. So now we would be sending this FEN to our backend, and now let's. I just want to make sure. Oh, so here obviously we need. So this is in Python. This is known as a dictionary. In JavaScript, this is known as an object. So save, and let's update this again and make. So now the idea is it prints like not found, because we don't yet have the route for our make move API. We need to create this. If I just go to this make move, you see like nothing is available here. So we now go to our backend code, and right below the route I want to define. Well, actually, let's skip the defined word. We don't really need this. So this would be the make move API, and I just say app.route and create the route make move like this, and the callback function would be def make move, and let's return just some string at the moment, so make move to make sure that it fires actually. And also it would be working here if we just run this in the browser, just after updating this obviously. Hold on a sec, what did I do wrong? Make move, this is a bit strange. Okay, now it works. Okay, but the browser sends the GET request, HTTP GET request, not the POST request, which means if we just try to do this via the POST request, it will give us an error 405, which means method is not allowed. So we need to explicitly allow the method, the POST method here. In order to do this, we need simply to say methods equals to and POST. We can list them like get, post like this, but we don't really need the get method here. So the post method is literally enough to have. And yeah, this is actually kind of it. So just save this. And now this data variable would be, well, I can just say console.log and this data. I will convert this to the object. So this would be like, later on this would be the object. So I can simply say like FEN, and well, now just use this dummy make move. Sorry guys, later on here would be the real FEN string. But now I just want to show you how this works. So we're making this network make move console. Hold on a sec, this is a little bit strange. So why don't we see? Because I didn't save it, obviously. Okay, we should see this make move. Yeah, this one. This object. Well, actually, dot FEN to see the bare string that we would be making use of a bit later on. So this is it. So instead of this make move, we'll have an FEN returned. Like we'll make a move. We'll find a best move within our chess engine, and we'll make that move on the internal board of the Python chess library, and then we'll convert it to FEN string, and then we'll return this FEN string back, and then we'll adjust the board position in the UI based on that string. That's it. Okay, so let's now do this step by step. So actually, well, I'll probably leave this as is at the moment, and let me reference the documentation. So I need, well, first let's import the dependencies. So now I can say it like so. I'm not using, I'm not going to be instantiating the chess engine at the moment, because the default mode of automatically restoring the web application would stop working after this. Oh, probably because of sharing the same thread, but I might be wrong though. So at the moment I just try to make use of all the additional stuff, and then at the very end we'll connect the chess engine. So here we want to initialize Python chess board instance like this. Also before this we actually need to extract FEN string from HTTP POST request body. So in order to do this, this is another important thing. So FEN, and in order to do this, I need to say request.form.get, and then the parameter name, which is FEN. So what I've just done, so here I'm setting this FEN parameter, and this is an object, and on Python side it would be converted to a data structure called tuple. So let me just show you this. So print, let's say request form, and here request.form. By the way, in order to work with this form, I actually need to import it first. So I need to say from Flask import request, not the form, but the request, and probably it has dropped, yeah, due to the synthetic error. What? Okay. Request form save. Okay, perfect. And another thing I want to print is print actually this FEN. So print and FEN and FEN save, and let's have a look. So if we now just make a move, excuse me, oh, something has gone horribly wrong. Request, okay, just a typo here, sorry. Request save. Let's try again. So make move. Okay, and here on the Python side, this is what we have. So this is the request form. It has the type of immutable multi-dictionary. So this FEN and the FEN itself, so key and the value. In order to extract this value, we're making use of this line of code like request.form.get. So in case of post request, we need to get from the forms. In case of get request, we need to say request.args, and that allows us to parse the string query parameters. So that would be like request args. But as far as we are working with a post request, it's the matter of form. So when we have extracted this FEN, it's now available in the type of string, which is good. And now we can use this string in order to actually initialize internal board state within our Python chess library. So I just need to pass this FEN to the board constructor, and that should be literally enough. So let's update and run again. So okay, yeah, and I forgot to print the board, so let's print the board, save. Okay, it's quite pretty handy feature here. So we can print the board by simply passing the board instance, and it gets printed quite pretty nicely here. So let's make move, and here we got the board with the move e2, e4 being done on the internal chessboard. So now this position, so now again, like the square e3 is now set to in peasant square, and the side has changed to black from white to black. So now this is the real position that engine is already kind of ready to analyze, and this would be used in order to, so we would have been passing this internal board state to our chess engine instance when we'll create this. And the very last thing, well, not the last, but still, so let's actually try to create this chess engine instance. I want to make this create chess engine instance. I want to create this in the root route just before initializing the web application instance itself. So here we say engine BBC 1.2. Again, like if you're on Windows, this path might be a little bit different, so make sure to use the proper path. Just to give you an idea, that engine lives in the engine folder. Well, I hope it is there actually. Okay. Oh, it's too long, sorry. Let me just open folder like this. Yeah, engine is here, so everything is just kind of fine. Good. And actually now, yeah, I don't want this anymore. Save. So now this should start. Okay, so I've saved the code, so the web app has been restarted and this engine instance has been created. But from now on, unfortunately, I'm not able to change the code without and see the with the automatic restart of the web application. Now, from now on, I would need to do this manually. Well, most likely because I'm sharing the same thread for my engine, but while I'm not really sure if that is the case or not. But anyway, now our engine is active, which is already good. So, which means that now we can actually make it analyze. So let's grab this line of code and let's just call it like find best move. Let's say search for best move and paste this in. So our engine instance dot play method, and we're passing our board with the currently initialized FEN, which is exactly what we need. Time control is set up to this miserable 0.1 second, but I'm not going to be touching this at this moment because we need to make this just as a proof of concept. And after, now this line is important, so after the result has been achieved, we need to update internal Python chess board state. This is how it's done. And one of the most important things here, we need to return FEN. Well, actually, yeah, let's separate this to make it clear. So let's extract FEN. Let's say convert current board state. No, it's better to say extract FEN from current board state, and FEN would be equal to I guess it's done like board dot FEN. I think this is it, and here I can just use this FEN. Now I just restarted everything by hand. Oh, it didn't even kill. Well, probably, yeah, probably they do share the same thread, because it seems like so when I killed when I have killed the web application, the engine has been killed at the same time. So most likely they do share the same thread, I believe. Okay, so now it should. Yeah, now this stuff is going a little bit weird. I'm not exactly sure why this is happening. So just for some reason starting two engines. I didn't yet figure that out why exactly this is happening. So let's just ignore this. It doesn't affect anything really. And now let's try to make a move, and the difference now that instead of make move, we should be obtaining an actual FEN string that is returned, which represents the response, the board with the response by the opponent. So the very last but not least thing we need to do, so we don't need this stuff anymore. We actually need to, oh my god, if I could only remember how this is done. We need to say game.load and FEN. So data.FEN, I guess this is what we need. So here we load FEN into the current board state. But again, like, so we have a board state from Python chess library on the backend, and we have a board state from chess.js library on the front end. So Python chess on the backend, chess.js on the front end. And now we need to update board position, and this is done like board, yeah, like this, board position copy board position FEN. If I made everything correctly, this most likely should now be capable of actually playing chess. Okay, perfect. So this is what's happening under the hood. So we're making our requests, and backend actually receives those requests. Let me just close this console to avoid reloading images every time. So every time we're making moves, it kind of, you see, like engine is actually working and calculating. Ignore this unexpected engine output. We don't really care about this. So what we do really care about is that it actually works. And if we just go for a new game, it will start working like again the same. And if we go for sudden death here, then after getting mated, we're not capable of moving our pieces. So it represents that the game is actually now over. So starting from this position, starting from this point, we already have a very basic interaction with our GUI on the front end and the chess engine on the back end. And from now on, we can actually start adding some useful features to make more joy, basically, of playing chess in the browser. So this is it from my side regarding this video, guys. I hope you learned something interesting out of this tutorial. I really hope to see you in the further tutorials within this series as well. And in the next videos, I'm not really sure what exactly we're supposed to be doing and in what order, but in general, we would be adding some features to like start a new game, make move, take back, print in the FEN, the PGN, and things like that. So I hope this would be interesting as well. And this is it again, like from my side. So see you next time, and take care, guys.